Hello, everyone. This is Alfredo Abate, your current Chicago Oracle Users Group president. Welcome to today's webinar. As an attendee, you'll be in listen-only mode. You can ask questions in the chat window, which we will monitor. All questions will be answered at the end of the presentation. We'll also be streaming live on our YouTube channel, and the recording will be available there to view shortly after the presentation is finished. It's great to be here with you today virtually. For those that are new to the Chicago Oracle Users Group, we welcome you. Traditionally, our group meets between 4 to 6 times per year in various locations around the Chicagoland suburbs for presentations as well as hands-on workshops by Oracle experts, ACEs, and authors. With the restrictions in place due to COVID, we decided to go virtual to continue to deliver awesome technical content to our members. Today is our 15th webinar in a series of 20 that we'll be holding until November 18th. We are down to only 5 more presentations. I can't even believe it myself. So make sure to visit our website and register for those remaining ones. Our website is COUG.us, and it's also there in front of you. Our user group runs completely unfunded. Our members don't pay any dues, and our meetings have always been free. I'd like to take a moment to thank our sponsor, OAPS.NET Partners, for providing the Zoom webinar platform for us. They are an Oracle Gold partner and systems integrator with specialties in areas of financial business solutions based on Oracle applications, both on-premises and in the cloud. They provide services in the areas of AP automation, Apex development, database upgrades, and administration. Next week, don't miss our webinar with yours truly. That's right, you're stuck with me for next week. I'll be presenting on the Oracle Cloud free tier and show you what that is all about, but I'll also show you how you can use it to build proof of concept applications with freely available data from public APIs. You can register for that on our website right now. Today, we are super excited to have Oracle Developer Advocate for SQL and part of the dynamic duo team of the Ask Tom Answer team, Chris Saxon, on pattern matching and SQL macros equals pure SQL awesomeness. Hey, Chris, welcome.
Howdy, thanks, Alfredo. All right, shall I take over the screen share now then?
Yes, please.
Hopefully you've got my slides up now. Alrighty then.
I can see it.
Yes, great. Okay, so thanks for the introduction, Alfredo, and thanks for having me. As he says, please put your questions in chat. One of the great things about doing these kind of presentations is actually speaking to people and answering your questions. So if you're not sure about what I'm talking about as I go along, please put your questions in and we'll address them when we can. We should have plenty of time at the end to hang around and talk about stuff should we need to. So as you may have guessed, or if you know a little bit about me, you probably know that I like SQL. But what you may not know is I also really like running. And occasionally these worlds collide and they end up doing something crazy, like running the word SQL. Okay, so SQL's doing strange things to my brain. But it turns out it's also really useful for answering questions you might have about your training program. Things like, are you actually sticking with your training program? Are you getting any better? And so on and so forth. We'll see how we can answer some of these in this session. Before we do that, though, a warning. This presentation contains something that strikes fear into the heart of all developers: regular expressions. Now, before you start panicking and saying, hang on a second, Chris, I thought this was all going to be about SQL. It's all right. There's going to be a lot of SQL in this talk. But to really unlock the power of row pattern matching, match recognize, we will be covering regular expressions just a little bit. Keep it nice and easy for the purpose of this talk. Like I say, if you're not sure, get stuck, just put questions in the chat and I'll address them when I can. So, hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team, part of the Answer team on Ask Tom. It's my job to help you get the best out of Oracle Database and hopefully have a little bit of fun whilst doing so. So with that in mind, let's get started. So, as I said, I like running, and I used to do a lot of running when I was younger. I ran a couple of marathons, but then, I had some kids, and I pretty much stopped completely for several years. And due to recent events here in the UK, like maybe you in Chicago or wherever you are, we were placed under lockdown recently in the UK. So March, April, May, June, you basically couldn't leave your house. However, one of the few things you were actually allowed to go outside for was your daily exercise. So I thought to myself, well, I'll use this as a chance to get back into the swing of things and actually get back into the practice of running every single day. So lofty goal, right? Can I actually do this? So that's my first question I want to answer here. Am I actually doing this? So every day I go running. What I'm going to do is record the date, how far I went, how long it took me, and so on and so forth. And what I want to see is what my longest consecutive chains, or how many consecutive days do I actually keep going. So I want to split the data up into these groups. So we've got the 1st through the 3rd of April, 6th and the 7th, 10th on its own, and so on and so forth. Now, before we jump into the SQL, let's just take a step back and think about the problem here. That is, how do we know if the rows are consecutive? Well, how do we know if values are consecutive generally? Well, it's if the current value equals the previous value plus 1. We know 2 and 3 are consecutive because you add 1 to 2, you get 3. Nice thing about dates in Oracle database is the unit of arithmetic is the day. So you add 1 to a date, you get the same time the next day. So if we look at my table here again, we can see 2nd and 3rd are consecutive because we add 1 day to the 2nd, we get the 3rd. We know the 7th and 10th are not consecutive because the gap between them is 3 days, or more generally, it is not 1. So we're going to use this fact to build up our pattern matching expression. Brief note before we do that. So we got our table, select star from my running log or whatever it is. After that comes the match recognize clause. So the table is the input to match recognize. We'll do some processing on the data values in there. That's when our lovely regular expression comes into play. And that will then generate the output. That defines the rows and columns we see in the results. So our table's the input, we process it, and we get, as a result, another table, rows and columns there. And what we need to do in this match recognize clause is define some pattern variables, things we are looking for in the data, and a regular expression involving these. So what do I want to do? I want to find consecutive rows, those where the current value equals the previous value plus 1. So I'm going to define a pattern variable, call it consecutive. You call it whatever you want, but I'll give it a meaningful name here. So consecutive is current run date equals previous run date plus 1. Fairly straightforward. I then have my pattern, and my pattern here is going to be init. Come on, slides. There we go. Init consecutive star. And it's like, hang on. Okay. Can see what consecutive means. I've listed that. I've been talking about all that going on there. What's this init thing? There's no definition for it, right? What's going on? Well, you can define pattern variables on the fly in the pattern clause. And if they are not listed in the define clause, they're undefined, they are always true. So that means they match any row. So why do we need this? Well, let's think about the first row in the data set. So what we're doing is we're saying, if we try and match that to consecutive, we're saying, well, is the current row equal to the previous plus 1? Well, we're on the first row. There is no previous, right? So it doesn't compute, right? How does that work? It just doesn't. So by having our always true init or start variable, it gives us a convenient hook to then start the rest of the pattern. So we match our init variable. What we do is then work left to right through the pattern and down through the data set. So once we've matched our first row to init, we then check if the next one matches consecutive. And here we got consecutive star. So that's the star quantifier in regular expressions, 0 or more matches. Hopefully, I've got a nice big long chain where I go running like 10, 20, 30, whatever days in a row. Or maybe I'll just go running one day and then take a break, and one day and take a break again, right? Because we've already got our one row per minute. There could be 0 consecutive rows. So how does that work on our data set? Well, we start with our first row and start looking for the pattern. So we've got 1st of April, that always matches the always true init variable. We then move left to right through the pattern, down through the data set, and ask, well, is the next row, 2nd of April, does that match consecutive? Well, 2nd is 1st plus 1, so that matches consecutive. Same applies for the 3rd. We then go down to the 6th of April. Now, at this point, it no longer matches that consecutive pattern variable, right? So what we do is we stop the pattern, stop looking for that group, and start searching for the pattern again, working left to right through it. So 6 matches in it, and then so on and so forth through the rest of the data set like that. So this gives us the engine of our pattern matching expression. We've got our variables and our regular expression involving these. But there's something, a little thing missing here. I said, is the current date equal to the previous plus 1? But I haven't actually defined what previous means, right? So it's like, hopefully, if you run a select statement without an order by, well, the database is free to return the rows in any sequence it wants. It's the same with match recognize, pattern matching. Without an order by, the database can process the rows in any sequence. Now, I want to work through the data in date order, so I need to order by run date. Now, this is a technically optional clause in the sense that your query will work. You're not going to get an exception if you exclude it. But I strongly, strongly urge you to consider it a mandatory clause, because it is almost always a bug if you have a match recognize statement without an order by, or at least a bug waiting to happen. So we've sorted our data. Last thing we want to do here is say which columns we want in the output, and we do that with the measures clause. So there's 2 things I want to show here. The first row, or the first date in each group, and how many rows that are, how long the chain is. So we can do that with measures first run date, kind of does what it says in the tin, returns the value for that expression for the first row for each pattern. So this is going to be every row that matches that init variable. And then count is just the count star function we all know and love, just how many rows are there in this group. So that's kind of a bit of an overview there. And at this point, I'm going to jump over to a demo to show you how this works in practice. So I've got my running log here. Let's just double check that's all working. Come on, come on, what's going on there? Let's try again. Do I need to reset my connection? Something, what's going on here? Come on. Oh, joy of live demos, right? What's going on here? Let's just check some. Okay, hang on. I just need to All right, come on. I think I just had a bit of a, there we go. Yeah, the network blip, lost my connection there for some reason. Okay, so we've got my running log. There's all my data, and I've padded it out with a bit more information to make this demo a bit more interesting. So got a whole bunch of dates that I went running there. So here's that match recognize clause I just showed you. Find all the consecutive groups and report how long their chain is. So we'll run that, and we get our output that looks a little bit like this. And we can see, I'm not really sticking with this run every single day plan, am I? I'm actually like 2, 3, 1 day, 2, 3 days, 6 days at most in a row. Okay. So yeah, it's running every single day. It's a lofty goal, but it's something that frankly I'm just not going to do, right? Some days I'll do other forms of exercise. You need rest days, and some days frankly I just can't be bothered, right? So running every single day is an unrealistic goal for me, at least. And setting yourself completely unrealistic goals, it's quite bad. It's better to set yourself smaller, more realistic goals, things you can actually achieve, things you can do. So rather than try and run every day, what I want to do is try and run 3 days in a row and then take some unknown gap between them. So in order to do that, we only need to tweak the expression here slightly. I want to search for groups of 3 days in a row where I went running. In order to find that, all we got to do is change this quantifier for our consecutive variable from star, 0 or more, to exactly 2. So this lovely little curly braces syntax says there's got to be exactly 2 instances of that. So we've got 1 row followed by 2 consecutive. And we run that, and we get something that looks a bit like that. I've lost some of my NLS settings, but oh well. All right then. So there we go. We've got days I went running 3 times in a row. Now notice those 3 days are all reported as 1 row in the results. So I get the 1st of April and the 3 rows after, and the 2 rows after that as 1 in the output. What if I want to show all the individual rows, right? I want to see each day I actually went running. I want to see the distances and the times and so on, for example. So what's going on? What can we do about this? Well, match recognize has this implicit clause of 1 row per match. This works a bit like group by. Consolidate all the rows in the group together into 1 row in the results. If you want to show the individual rows, we need to change this to all rows per match. So we'll do that, and there we go. Now we can see all the individual rows and the times and distances, so on and so forth. So this is nice, but if you look carefully, it's perhaps not too easy to see, but there's a big gap here from run dates. So I've got 3rd through to the 13th. So I ran 3 days in a row, 1st through the 3rd, and then the next day that's shown in my results here is the 13th of April. So what happened to those rows on the 6th, 7th, and 10th? Well, they didn't form a complete chain of 3, so they didn't match the entire pattern. And if for some reason, you've got some input data or input rows that don't match your entire pattern, they get excluded from the results, right? This can make, writing these pattern matching expressions quite tricky. As much as possible, try and add these variables one by one. So what can we do about this? Can I see all the individual rows, all the rows that come from running log, even if they didn't form a group of 3 in a row? Well, yes, there's another implicit clause here after all rows per match. We can change this to with unmatched rows, or add this explicit clause here. And what that'll do is show me the entire input. So now we can see 6th, 7th, and 10th in April are now back in results. I can see I went running, but they didn't form a group of 3 days in a row consecutively. And notice they are null for all these values in the measures clause. So even though 6th of April, it matches that always true init variable, it's not tagged in the results because it's not part of a complete group. It's got to be any row followed by exactly 2 that are consecutive with each other. So again, something little to watch for if you're writing this out. So we've got this match recognize clause, and there's various ways we can fiddle and tweak with it to find consecutive rows in your data. So at this point, I'll jump back over to the slides. So hopefully at this point you think, oh, that's pretty neat. This is pretty cool. And hopefully you'll go back after this and tell some of your colleagues about this and say, oh, I learned about this cool new pattern matching thing, and they'll be interested in kind of ask about how it works. Or maybe you've got this kind of problem to solve right now. Finding consecutive rows is a relatively common business question. Things like, show me how many consecutive days a customer visited the website. What's their longest streak? How many consecutive days did we have complete availability on the website? Or how many consecutive days did we do successful deployments? How many consecutive days did sales exceed 1 million? That kind of thing. It's fairly common. People ask this kind of question, or they want to see what the longest chain is. So either you've explained this or you've written some code and people are reviewing it, and there's probably some wise person on your team who's looking at this and going, well, this is pretty neat, this match recognize stuff. Can we make this reusable, right? Can we take that match recognize stuff and apply it to other tables? At which point you're just kind of like, let me get back to you on that, right? And this kind of strikes at one of a criticism of SQL, which does have some validity. It lacks composability, the ability to kind of define SQL fragments or components, which you can then build up into larger SQL statements. Now, this isn't entirely true. You can, of course, create a view. So we can turn this into a reusable query. So I'll call it consecutive days, call it whatever you want. We can now join to this, use it in other parts of the application as necessary. But it is bound to that running log table. Now, this might be fine if you're building like a Strava or Runkeeper type clone, where you're just tracking users' activity for their runs or whatever it is. But what if you want to change which table this is for? How many days consecutively did someone actually log into your application as well as go for a run? Well, how do we pass dynamic tables to this? And this is where things just kind of they get messy in SQL, right? It is possible to do it, but you have to fall back on dynamic SQL. Do something like this: open a cursor and pass it in the table name, and concatenate that into the string for the query that you're running. Bit messy, and of course there is a massive, massive problem here. As soon as you have string concatenation of user input to a SQL statement, you're at risk of SQL injection, right? And this is particularly problematic for identifiers, table names, column names, that kind of thing, because you can't bind them. You can't use bind variables in these scenarios. So you still need to concatenate them in, and you need to do something like this. Use DBMS assert to validate it is in fact a genuine table name and not some hacking attempt like that. So it's a bit fiddly, right? Yes, we can sort of kind of make this dynamic, but we've got to do this stuff to open a cursor. And even then, we've got a ref cursor. How do we join to that? You've got to do something like turn it into a table function. Oh, this is just getting painful and messy, right? So this is, like I say, striking at the heart of this argument. SQL lacks composability, the ability to define fragments which you can then build up larger SQL statements. Until now, that is, with the advent of SQL macros. So these do exactly what the problem I've been describing. They allow you to define SQL fragments, so part of a SQL statement, and then use them in larger SQL statements. So what are these and how do they work? Well, the first thing to note is SQL macros come in two flavors: table and scalar. So table macros are ones you use in the from clause. So instead of a real table, a view, a subquery, and so on. And scalar macros are ones that you use everywhere else. So basically everywhere else, it is legal to use a PL SQL function. So select clause, the where clause, the order by, so on and so forth. So they're both cool, both very useful. I'm going to be focusing on table macros for the rest of this talk for a couple of reasons. First up, they're just a bit more interesting. There's some cooler things you can do with table macros. But secondly, and perhaps more importantly, only table macros are the ones that are available to you right now today. So SQL macros was originally slated to be a 20C feature. Table macros themselves have been backported to 19, but only table macros. Scalar macros, you are still going to have to wait for the next release of Oracle Database for, sadly. So I'll keep going, talk about table macros. So how do we actually write one? Well, let's imagine I'm writing a generic top N macro. So pass a table, number of rows, and we'll get that number of rows from that table. So the first thing I want to do is write a statement that does that. So select star top N.tab table, fetch first, number of rows only. So that uses the fetch first clause. So I've got my SQL statement. Now, this is a SQL fragment. So I'm going to return this as text. Okay, so just return this into a string. And I'll create my function, which returns a varchar 2, which is a SQL macro. And the parameters I've got in this case are the number of rows and the table. Table name uses that lovely DBMS TF data type there. That tells it is in fact a real table in the database. So this is the SQL macro. This is all we need. So how does it work? Well, when we actually call this, what the database does is it does a find and replace of the exact text that you have passed for the actual parameters and replaces those for those in the text that it returns. So this is one of the things that's best explained by example. So let's say you're doing a top N 5 from employees. Get me 5 rows from employees. So what it does is it says, okay, tables employees, and we're getting, the number of rows is 5. So the SQL statement it runs is from employees, fetch first 5 rows only. Okay, fairly straightforward. Most people will get that. What happens if we're going to use a bind variable? Right now, what happens here? It doesn't peek at the bind variable, evaluate it, figure out what it is in any way whatsoever. No, it literally takes :bind and makes that part of your final SQL statement. So what we get here, we're selecting from the jobs table, fetch first bind rows only, okay? That is exactly what the SQL statement is. We don't try and figure out its value for the bind and make that the statement. No, we make the bind variable itself part of the SQL statement. Okay, so that's basic example. What we can now do is use this concept to make our generic consecutive rows function. So get consecutive rows, we'll pass in a table and the column we're searching for consecutive values on, and put our match recognize clause in there. So at this point, I will jump back over to my demo again. All right, so there we go. Let's see. Actually, before we do that, I'll just rebuild it because I've lost some settings when my connection went. Right, there we go. All right, so let's start with that generic top N function. So we can see there's a SQL statement as a string. Let's create that function, and I'm going to get 5 rows from employees. We're going to get 5 rows in the output. So let's use a bind variable this time. So we'll pass a bind. I'll say 1 row, and there we go. We get just 1 row. If I run it again, pass in another row, pass in 10. Sorry, that's incredibly tiny. You probably can't see that. I'm not sure, I can't increase the font on that, sadly. There we go. We can see we've got 10 rows from that. I can also do slightly more crazy things. I could actually pass in a subquery for the number of rows. So select 2 rows, and this subquery is part of the SQL statement. I could do DBMS random.value, so return a random number of rows between 1 and 10. So let's run this, and you see if I run this a few times, we'll get a slightly different number of rows each time. So there's 5, there was 4 a second ago, a few more. So every time we run this, we're getting a slightly different number of rows. And that's because this is part of the SQL statement. So how do I know that? I'm just saying, you're just saying that, Chris, right? How do I know that? Well, we've got this lovely DBMS utility expand SQL text. Let's just run that, and this will show us, it'll spit out the SQL statement that the database runs. So we'll just copy that, paste it, format it. So we can see there's a lot of nested selects, but ultimately we get down, we can see there's my table name, and there's the call to DBMS random.value. So this is exactly the SQL statement that gets executed. It hasn't evaluated that, picked a value, 2, and made that part of the statement. No, it has literally taken DBMS random.value 110 and made that part of the SQL statement. So pretty neat, right? Pretty neat. We've now got my generic find consecutive rows function. Okay, let's close that. So here's one I made earlier, just in case that demo didn't work for some reason. Okay, now thing to note here, some other things to cover off. The table we pass in has to be a real, genuine table that we have actual privileges on. So there is no table invalid table, at least not ones that I've got select privileges on. So if I run this, we're going to get an error. Doesn't exist. If I try and start doing some lovely kind of SQL injection-y type attacks like this, where I've got a string and do the close quotes 1 = 1 nonsense, again, this is not going to work because this is a string. It's not an identifier. Doesn't compute. It will not allow us to do this. You might go, okay, well, I know how to turn a string into an identifier. We'll just double quote it like this. So we'll put some double quotes like that. Running log where 1 = 1. Again, what it's searching for now is a table with exactly this name in my schema. Unsurprisingly, I've got no table called that in this database. So it's going to get an exception. There is no table like this. So this is, compared to that ref cursor approach where we were concatenating in and had to worry about SQL injection, that is no longer an issue here. So we are safe from that perspective. So that was our generic top N. It's useful just to kind of explain the functionality. I'm not sure you'd really write this because, after all, select first, fetch first, N rows only is pretty easy itself. But what about our generic top N, generic consecutive rows function? That is something we might want to apply. So we've got our consecutive rows, got a table and column. Let's create this. Now, one of the things you might notice here is you're like, hang on. Why have I concatenated in that column name? Why haven't I just, listed it here in the string like with the table? Well, what this call thing here is it uses the columns pseudo operator that accepts a comma-separated list of column names. So we've got basically an array, and we're taking an array. How do we turn an array into a string? Well, there isn't really a native way to do that in SQL, so we need to pull out the element we want. So we'll get our values like that, create the function, and now I can do my get consecutive rows and find the things I want. Lovely. So this is exactly the query I ran a few minutes ago, just in a nice neat wrapper that is now reusable, and we can apply to other tables and columns in the database. Just to note on this columns operator, it has to be a real column in this table. If I pass in the lovely dummy column from Dual, well, that doesn't exist in this table, so this doesn't work. We get invalid identifier. Same if I try and quote it as well. So again, it's much harder to write insecure or SQL injection vulnerable code. Not impossible, I must say, but just much harder to write vulnerable code using macros compared to other various approaches. And like I say, we can now use this and pass in other tables and other columns. So rather than finding consecutive days, I could search for consecutive times. I'm not quite sure exactly what this means, but we can do it. So what it's saying here, start value 280 seconds, 2 rows. So that means I went for a run that was 280 seconds long and one that was 281 seconds long. And I've got 300, so 300, 301, 302. Any value, any column which we can do that, does it equal to the previous +1? So numbers, dates, timestamps, we can apply this logic to. So we can do it for any column in this table. We can also pass in other tables, and they don't have to be real tables. So here I've got a virtual table with clause. So this is generating the values from 1 to 10 and 21, 24 to 24. I can pass that with clause, that named subquery, to my consecutive rows function, and voila, there we go, we've done it. We've found first in each group and how many there are. So I've now genuinely got this generically reusable function which we can apply to any table and the relevant columns in the database. Pretty awesome, right? Okay, so at this point, I will jump back over to the slides. So hopefully you're looking at this and going, yeah, that's pretty cool. We can write these generically reusable functions, pass other tables or columns to them. So you're like, come on, we need to upgrade to 19C. Let's get out there. Let's get onto this so we can start using this functionality. And again, you go around to your colleagues and say, come on, let's use this. Let's do this. What does someone say? Well, can we have a meeting about that? Can you just put it in my calendar and we'll discuss it later, which is, code for, I don't want to do that. Bother me later, right? So anyway, you want to go out there and get people upgraded, and so we can take advantage of this cool functionality. So now you've got to play the find the slot in the calendar, right? So let's keep it nice and easy. Imagine you just got 2 people to worry about, yourself and your boss or whoever. All of these things marked in red are times that are blocked out in the calendar that they are already busy. So what we want to do is find the first time or times that both of you are free, so you can quickly jump in and book that slot. So we want to find this gap here. So how can we do this? Well, before we do that, just a quick note on date ranges or date intervals. I'm going to be working with closed open intervals, which means that with values where it's greater than or equal to the start and strictly less than the end. As far as I'm concerned, this is the right way to do these kind of intervals, where you're finding things in a time range. People have all sorts of weird and wacky ways of doing this, whether they include or exclude the boundary conditions. As far as I'm concerned, it should always be greater than or equal to the start, strictly less than the end. Anyway, if you want to do it other ways, well, go ahead, knock yourself out. Okay, so we can solve this with pattern matching. But how? Well, again, how do we know where the gaps are? How can we do this? Well, what we're searching for here is we're going to sort the data by start date and then end date, and then search for rows where the maximum end date so far is less than the next start date. Okay, this is one of those things that takes a bit of thinking about. You're probably scratching your head, what's going on there? What do I mean by that? best illustrated with an example. So what I've done, taken that calendar we saw a few slides ago, turned it into a table of data, sorted by start time, then end time. So we'll start with our first row. So the running maximum end date so far is just the value for the current row, 10 a.m. We're going to compare that to the start date for the next row. Well, 10 a.m. is after 9, so there is no gap. Let's go to the next row. The maximum end date we've seen so far is noon. Again, we'll compare that to the next start date. Well, noon is after 10. Again, there is no gap. Move down to the next row. Now notice this next row, the meeting finishes at 10:30, but the maximum date we've seen so far is noon, 12 p.m. So we keep with that overall running maximum end date. Check. Is that greater than, or is that less than the next date? Nope, it's greater, so we've still got no gap. We'll keep working our way down through the data set till eventually we get down to this row here, this meeting that finishes at 2. Compare it to the next start date. That starts at 3. At last, we found our gap in our data, so we can book that meeting. Okay, so what we're doing here is checking, is the running maximum end date less than the next start date? Okay, so we're going to create a pattern variable for that condition. Define the gap as the maximum end date is less than the next start date. So notice, once we've written clearly what it is we're searching for, what those variables mean in English, their definition quite closely matches what we just said, that sentence has just been saying. Okay, so that's the definition of our pattern variable. What is the pattern involving those? Now, this is where things get a bit more interesting. Pattern here is gap, no gap. So no gap here is my always true row. But what's with these lovely little curly braces around that? What's going on there? Well, this is the exclusion operator. So that means we can match those rows, but hide them from the results. So what we're going to do is we're going to work through the data set, check each row, does it match gap? If it doesn't, we'll then ask if it matches no gap. That's always true. So it doesn't match gap, it's definitely going to match no gap. So we're going to get those no gaps, but we want to suppress them from the results. We only want to show the gap rows in the results. We want to show all the individual rows here. We don't want results squashed down to 1. Could be lots of different gaps. And we'll finish off the query a bit like this. And again, we can now create our SQL macro, find the gaps, pass in our table and our date columns, and return that expression. So I'm going to jump back over to our demos again, show you how that all works. Oh, yeah. One other thing I forgot to mention previously, we can filter the data beforehand like this. So if I want to find my consecutive dates where I went, how many consecutive days did I run a distance of 2 kilometers? So we can do like this, happen just once in my data. Anyway, okay, so let's change my date format. We'll just show the times, make it a bit easier to understand. And here's my meeting calendar. So there's my start and end dates. That's what we just saw in the slides. And again, we're going to do the find the gaps. And there we go. We've got our row and our start gap and end gap. We've got our slot there between 2 and 3. Let's jump in there, book the meeting so we can convince everyone that we need to upgrade and use this cool new stuff. Okay, so we've got this gap, no gap, but what if we want to show all the rows here? So previously, when I was saying, show me consecutive, every time I ran 3 days in a row, and I wanted to include the dates where that wasn't true, we can have that all rows with unmatched rows. Sadly, this with unmatched rows clause and this lovely little exclusion syntax, and I messed up my query there a bit slightly, let me just fix that, are incompatible. We can only use one or the other. We can't use with unmatched rows and no gap. It's like, no, okay. Could make debugging a little bit tricky, right? We were trying to figure out what the problem was here. How can we see this? Well, we would have to remove the exclusion syntax from this. So we can remove the exclusion syntax, gap or no gap. That's nice. But now we see everything. It's like, oh, okay. How do we get around this? Well, remember, match recognize returns a table. So how do we filter tables? Add a where clause, right? So if we want to see just the rows where there is a gap, we just check where that classifier function. So this classifier returns the name of the pattern variable that matches. So it will be gap or no gap. We'll run this. Hopefully that will work. We can see there is just the row that is the gap. So there's different ways you can tackle this problem. They have their various pros and cons, kind of depends what you want to do with your results, but ultimately they solve the same thing here. All right, so we've got our function here. Now let's turn this into a reusable component with our SQL macro. So we've got find the gaps and date calls. So we'll create this. And notice we are passing 2 columns in here. We need the start date and the end date, right? So I need to pull out both of those individually and concatenate those into results. Let's create the macro, there we go. And now if we do find the gaps for my meeting attendees, and there we go. We just got the 1 row from 2 till 3 showing us the gap in the calendar. So we got our lovely find the gaps reusable function. We can apply this to other tables. So at the start, I said I wanted to search for consecutive days, find my longest chain of consecutive runs. Another way we could actually approach this problem is the opposite. Show me every day I didn't go running, right? Instead of showing me all the chains I did go running, show me every day I did go running. I prefer to show me the days I did go running. It's a bit more encouraging, motivating, as opposed to showing you all the days that you failed and you didn't do it, right? But we could take that approach. Finding the gaps and finding consecutive are kind of opposite ways of solving a similar problem, depending on exactly what you want to see. So how do we do that? Well, first thing I want is I'll actually need to get a row for every single date in the range. So to do that, I've just created a generic calendar dates table, which has a whole bunch of days in there. And I'm going to outer join my running log to that. So we've got our query here. We see every single day, and I've used the lead to show me the next date I went running. So we can see after the 3rd, the next date I went running is, well, there is no, the next date I went running was the 6th. So because that's null, I want to return the current date. So we'll hide that. So this will form our start and end date columns. So this run date and the next run date. And I want to find these gaps here. So what we can do is turn this into a with clause, make it a name subquery, pass it into my find the gaps, pass in my start and end date columns like that. And there we go. We found the days I didn't go running. Or did we? Well, not quite, right? Notice my start and end gap. I said my gap starts on the 3rd and finishes on the 6th. Those are both days I actually went running, right? Something not quite right here. We need to add on 1 date to the start and subtract 1 day from the end. So again, this is where you need to be careful with date ranges and boundary conditions and things which happen at exactly that particular time. But if we do that, add 1, subtract 1, we can now find like the ranges of days where I didn't run at all. So we can see 4th and 5th, 11th, 8th and 9th, 11th and 12th, 16th and so on. So another way of solving the same problem. And again, if I want to find the actual SQL statement that executes, we can do the lovely DBMS utility stuff, get that out, and see there's a lovely, nice big SQL statement like this. It's match recognized, all the pattern, loveliness, and so on. So very, very cool. Alrighty then. So we're getting towards the end. If you've got questions, please put them in the chat. I'm happy to stick around for a while to answer questions you've got about this. But to recap, to match recognize, what this is great for is searching for sequences of different events across rows. Now, there are lots of types of queries which are somewhere between very tricky to effectively impossible to write using standard SQL. Match recognize makes them really, really easy. Okay, things like a classic example is searching for trends in stock market prices. So day traders are always looking for those things like, okay, if the price goes down 3 days in a row, up a day, down a day, and up 3 days in a row, like a W pattern, that means something, so we should buy or sell or whatever. So they're always looking for trends like that. Trying to write that kind of query with just regular SQL, even with analytic functions, very, very messy. match recognize is very simple. We'll define two pattern variables. Up is the price greater than the previous day. Down is the price less than the previous day. And then we can just write our pattern up, down, however many instances of each of those that we want. Very, very easy to do. More importantly, very easy to change if you want to tweak how many days in a row or the sequence of ups and downs that you're searching for. Very powerful, very, very cool. But as I said, for a very long time, and just SQL in general, if we got this nice function, find consecutive rows, we want to apply that to other tables. Well, you kind of couldn't. I mean, you could, but it was messy and a bit of a pain. SQL Macros makes that really, really easy. We've now got these reusable components where we can pass in a table, pass in the columns, and we've got that generic function at last that we can apply to any table and any columns. So I contend when you've got match recognize in SQL Macros, what it gives you is pure SQL awesomeness. Oh yes, all right. Okay, so here's some links for you. One of the top question from any session that I ever do is like, can I have the scripts for this? Right, so here's some links to the scripts from these sessions. So these are in live SQL. You can fiddle around with them, download them, and do what you want with them. But that was all I wanted to cover. So let's see, questions. So Timo, SQL ID of a macro query with a different table parameter passed as binds. So Timo, are you trying to pass the table name as a bind? Because the short answer is you can't bind the table name, okay? It has to be a real table name. And because it's a different text of the SQL statement, it is a different SQL ID. Is that kind of what you're asking? Can you bind the SQL statement? I will show you an example. Let's pull this up. Let's use my, there we go. So if I try and do, I'll bring this down here. If I try and do : meeting attendees for binding the table name, I'll just call it, I'll call it running log, because that is a real table. It's going to go, you know, you can't do that. This parameter, if I scroll all the way back up, this thing checks it is in fact a genuine table name. And if you played with polymorphic table functions that came in 18C, it's the same principle. So every time we pass in a different table, so we pass in running log, it's a different SQL statement, so it's going to be different SQL ID. So I hope that answered your question, Timo. You could let me know either way, that'd be grand. All right, any other questions? Anything else anyone wants to ask, cover? You know, like I said, I've got my SQL developer up there, so we can do some more examples if you want to try other things, other ways of playing with this.
Doesn't look like any other questions are coming in. We'll give everyone about another 30 seconds.
Yeah, they say people always want the slide where you like give them the links and stuff, so I'll leave this up for a bit as well, I'm afraid.
Yeah.
I would say as well, if you know, pattern matching, it's a really big feature, and some of you probably there kind of like trying to get your head around it. On Live SQL, we do have a lot of work tutorials showing you how all these different components work and how to try them all out. So if you want to have a bit more of a fiddle and a bit more of guidance with this, which I completely get, you know, first time you hear it, see this, it's like, I'm struggling to figure out what's going on. So go to Live SQL, livesql.oracle.com. That's actually these links here, and search for pattern matching or match recognize. A whole stack of tutorials showing you how these all work, various things you can do with them. So have a fiddle around with them and play with those too. All righty then. It doesn't look like we're going to have any other questions, Alfredo.
All right. Well, Chris, thank you so much for presenting all the way from the UK. We hope to have you again in the future. We would love to have you back. And I think that's it. So yeah, I will get the slides from you if that's okay, Chris, and we'll post that on the COUG 20 for 20. So yep, you can download them there. And then if you want to go back and watch this video again, it's up for you on YouTube already. It'll say live for a little while and then it'll switch to a regular video, but yeah, you should be good to go. And next week, if you didn't catch the beginning, I will be presenting next week on the Oracle free tier and how to do proof of concept systems with applications, for applications with free data. So we'll catch you there at same bat time, same bat channel. And thank you, Chris. Take care.
Yeah, no worries. Yeah, you too, Alfredo. And I hope you stay safe, folks. And I hope we can actually see each other for real soon. All right.